Okay, so again, some help with the 5.5 concept checked if you need it. So the first question here, it tells us that -1 is a zero of this equation. And so what it wants us to do is write the product as a bunch of linear factors. So what will end up happening is you'll end up having three different parentheses here. So again, if I know that -1 is a zero, I know that x plus 1 would be a linear factor, it would be one of the parentheses. And so what I would want to do is I would want to do synthetic division with the -1 to go ahead and figure out what the answer would be, because then again, once I get that answer, then what I'll be able to do is either factor it to find another rational root, or what I could do is I could use quadratic formula to find an irrational root or an imaginary root. So from there I could write it as the next two parentheses as whatever the two other solutions are. If they're whole numbers, it would just be, plus or minus whatever that is. If it's an imaginary number, then I would put the two imaginary numbers in there, just like we did in the notes. This one, you are going to list all the possible rational roots. So just like we did in the notes, the one thing that's important with this one is make sure that no value appears more than once. So even reduced forms, make sure that you don't list them. So you do plus and minus, and then just do it a bunch of times, and then take your whoopsie daisy. And then for each one, again, I've got 3 here. So my numerator would be 3 and 1. My denominator could be 7 and 1. So I could go 3 and 1 and 1/7 and 3/7, plus or minus for all those. So that would be how you do that. Just make sure again that you don't list something more than once, or else it'll count it as wrong. This one's just like the other one. List all the possible rational roots. Be careful that your leading coefficient, you got to put it in standard form first. So this 4x to the third should be in the front. The 4 should be last. That'll give you all the possible rational roots from there. Here it gives you an imaginary 0. So again, I know that if this is one of the imaginary zeros, then I would know that its conjugate would also be a 0, so -3 minus I would be another 0, and then I could use rational root theorem to find the other rational root. So I could go through my list, I could use my table on my graphing calculator to find the other one, and then I could just list out the 3 zeros that I have for that. Question number 5 is kind of interesting. So again, I've got a polynomial with a degree of 12. And so what I know with a degree of 12 is that it'll have 12 solutions. And so since it has this imaginary solution, I know its conjugate will also be, so 4 minus 4i would be another imaginary solution. And since this -3 has a multiplicity of 3, that means that it takes up 3 zeros worth. And so another 0 would be the conjugate. I could put 4 minus 4i. Here, the maximum number of real zeros. So I know that 2 are going to be imaginary. So that means all the rest, and then I know that this has a multiplicity of 3. And so what I would know is that this is taking up 3 zeros. This is taking up 2 zeros right there. And so I'd be able to take those 12, take away my 2 imaginary ones, and so I'd have 10 left, because it's not necessarily distinct. Could be this -3 repeated, okay? This one right here, what is the maximum number of non-real zeros? So remember that non-real zeros have to go in pairs. So this is going to have 3. This is taking up 3 solutions here. So that would take my total degree down to 9 other solutions. And so since imaginary numbers have to go in pairs, it has to be an even number. So this would end up being 8. This is the one that's a little bit tricky right here. So I can go 4 minus 4i, and then right here I can go 10. There you go, okay? So this one's a little bit tricky, but again, knowing that non-real zeros travel in pairs, this has to be an even number. This, I can just take away the imaginary solutions that I have, and here, this is the conjugate of the imaginary. So I hope that made sense.